Now, all right, so we're looking for the missing side of a triangle. Okay, so I remember pretty much what you guys are gonna be looking at is either triangles or some kind of polygon shape in this week's work. So now we have two sides here in this triangle, and the goal here is to figure out the missing side. And that's what you're doing with a lot of these shapes that we're looking at. So the missing side is this one right here. Okay. Now, Pythagorean theorem only works with right triangles. So use with right triangles. And remember, right triangles are right triangles when they have a 90-degree angle. If you have highlighters, I recommend having highlighters. I always try to keep like 3 colors handy. So here is our right angle. So I'm just kind of drawing this over here in the corner. Remember that that right angle is 90 degrees. Zoom in just a little bit. Okay, so we're only using this for right triangles. Okay, so before we write the formula, we need to define what the triangles are, or the parts of a triangle. Okay, so what we have, let's say we label this triangle A, B, and C. Well, A and B, we call those the legs. So legs, and you'll see that in delta math. When it says legs, it's talking about these two sides, the ones that are right next to 90. Okay, next to 90, or next to, we'll say next to 90 degrees. So make sure you distinguish the two. You got legs, and then the other one, in this case, C, you guys remember this word, hypotenuse. This one is across from 90. So you got sides that are next to 90, those are legs, and across from 90, that's the hypotenuse. All right, so now the formula we're going to use is a squared plus b squared equals c squared. There's your Pythagorean theorem. All this means is that when you square a and you square b and you add those two up, it should equal the square of side c. And that helps us find missing sides. So now we're going to take our side, which over here, we can label that whatever we want. Now remember, this is a leg, the missing side. So we can either call it A or B. It doesn't matter what you call the missing sides, as long as the ones that are next to 90 are A and B, and the one across from 90 is C, okay, or your hypotenuse. Okay, so we'll just call this A, and we'll call this one B. So the missing side is A, so we'll say A squared plus B squared, which is 6, is equal to the hypotenuse squared, or C squared. Okay, so now we'll simplify. So first we'll square, we'll do exponents. 6 squared, remember that's 6 times 6, so 36. And then 10 squared, 10 times 10, 100. Okay, then we just need to isolate A. So minus 36, minus 36. And A squared is equal to 64. And now here's the key step, is that you need to square root. Square root both sides. Anytime you guys see a square on your variable, if it's x squared, b squared, c squared, r squared, z squared, whatever squared, you're going to square root both sides of the equation to solve it. Okay, so then what I do is once I square root a squared, what it does is basically cancels that 2, cancels the exponent. Okay, and then I take the square root of 64, which is 8. So our missing side is 8. The second set of problems gives you a description of the triangle. So it says one of the legs of the right triangle measures 16 centimeters, and the other leg measures 8 centimeters. Find the measure of the hypotenuse. Also, it says round to the nearest tenth. So let's write all this out. Okay, so it says that one leg is 16 centimeters. One leg is 8 centimeters. Let me make sure I wrote that right. Yep. And then it says find the hypotenuse. Also says round to the nearest tenth. Okay, but we'll include that in the end. All right, so remember, these are right triangles. So however you draw your triangle, it does not matter. Just make sure that one of the corners has a right angle, that 90-degree angle, a little box. Okay, now remember the legs are the two sides on the sides are next to the 90. So that means that you could put 16 here, or you could put 16 here. It doesn't matter. As long as those numbers are the legs. And then it's asking you to find the hypotenuse, this side. So that's what we're looking for. All right, so again, just like before, let's label it. Last time I labeled this one A. I'm going to label this one B. Because again, it doesn't matter as long as A and B are the legs and C is the hypotenuse. Okay, so now we're going to do A squared plus B squared. So 8 squared plus 16 squared equals C squared. Same steps as before. We're going to simplify it out. So 8 squared is 64. I can't think off the top of my head what 16 squared is. Some of you guys might already know it, but I'm going to bring out the Desmos. 16 squared is 256. And then we got to add these up. So 256. And do. By the way, a feature on Desmos is, let's say you have an answer here. If you want to use that answer in your next line, which by the way, to get to the next line, I just press enter, go down here and I can press answer. And it'll basically bring that answer down to your next line. And now I can add the 64. Okay, so that's a cool feature there. If like you don't want to retype everything, you can just bring it down, especially if it's like some long decimal answer or something. Okay, so 320. Okay, just like before, we're going to square root both sides. And remember, we only square root once we're simplified down to one number. So you don't want to simplify like 64 minus 36 or something like that. You should only have one number over here in the square root before when you do that. Okay, so now we're going to use Desmos to figure out the square root of that and clear all this out. So I'll hit the square root button first, and then I'll type 320. Okay, and notice that we did not get a whole number. We got a decimal. Okay, so we're going to write down 17.8885. We're going to write down all those digits. If you guys remember, the problem said we need to round this. 8885. And this is a good example to review rounding. Okay, so it says in the problem, sorry for all my switching back and forth, round to the nearest tenth. All right, so let's write that over here in our notes. So round to nearest tenth. Now remember, the tenth is the first number after the decimal. So the tenth is that first 8, not the second 8, but the first 8. Now what I need to look at is the number after that. So I'm going to look at the number after, and that's going to tell me whether that first number is going to change or not. Now remember, if you're going to round up, that number next to it needs to be either a 5 or greater. So basically 5, 6, 7, 8, or 9 will round this 8 up to the next digit. In this case, it will go up. So that means that this, I'm going to add 1. So this will be 17.9. And when you round something, you draw this little symbol right here. That means approximate or about 17.9 because that's not the exact answer. It's about, okay? But that's what you're going to actually type into Desmos. So let's make sure we got it right. So 17.9. And what did it say? We're good. Okay, so now, again, look how Desmos laid this out the same way, pretty much as we did, the square root here. Then they did the approximation sign. But again, remember, when you type into Desmos, you only need to put the number, not the whole thing, okay? And I'm going, so round up if number, put a little asterisk here, after is 5 or more. So you guys watching this recording, go ahead and copy this in your notes, pause the video for a second, and copy these down. Scale factor. Okay, scale factor. Now, I'm referring to the worksheet. So you guys are going to have a worksheet here in Schoology in this folder number 2 in folder A. And you're going to have similar polygons that you could see the shapes all look very similar, and they're like the angles are the same, but one smaller than the other, right? And they're corresponding. This is called similar, not congruent. The next one you guys are going to see is congruent, which means they're actually equal, like everything is the exact same. Similar just means that like the sides are proportionally the same, or in other words, inside angles are all the same, okay? But the sides will be a different size. So it's just different scale, okay? So what you're going to have is it's going to say, find the scale factor of the smaller figure to the larger figure. So in other words, we're going from the small to the big. So if you guys remember last week, I said we're to find the scale factor, we're using the new shape and the old shape. Okay, well in this case, the new shape is the bigger one. The old shape is the smaller one, okay, for at least these ones that you're in your on the worksheet. Okay, so scale factor is always going to be a new side. You take a new side and then divide it by an old side. Okay, for this worksheet, it's the same thing, except we're taking the larger side and dividing by the smaller side. That corresponds. Keyword, corresponds. Okay. So I might kind of put this on the highlighter like this. So what's important is that sides need to correspond. Correspond. Now, that word right there, correspond, means that on the two triangles, they're in the same location. So these two triangles are oriented the same. They both have like kind of this point up, pointing up. So what that means is that 8 on this triangle corresponds to 12 on this triangle. Okay, they're in matching locations. Now, in some of the triangles we're going to see later on, the next triangle might be kind of turned or transformed in some way, and you're going to have to kind of use the letters to figure that out. But right now, you're just looking at the picture. This one on the top left and this one on the top left are corresponding. So to find the scale factor, again, we're taking the new side divided by the old side, or in this case, the larger side divided by the smaller side. And here, 12 corresponds with 8. And in the same way, 15 corresponds with 10. So I can use either one. I can use either one to find the scale factor. So let's say I'll take the 15 and the 10. We'll use those two. So remember, the new side, or larger, divided by the old side, or smaller. And that'll be our scale factor. Now, in this case, I can't divide 10 into 15, so I've got to reduce it. I can divide both of these by 5. So that means this will be 3 over 2. So my scale factor for these shapes is 2. Now later on, like, why would we use scale factor? Because scale factor helps us find shapes for the next size. And when you think about like how is that applied, like let's say out in the world, and a lot of times when you build something, you have to create a model. And for instance, like when they build like a building, right? They're not going to, a model isn't the actual size. They're going to create a scaled down model. Okay. And they have to use the scale factor, which they also call ratio, and figure out, okay, well, if this building is 1,000 feet tall and we want our model to be 2 feet tall, what's the scale factor we have to use to figure out all the different sides? Well, you have to come up with a scale factor or a ratio, and that helps you figure out all those dimensions so you can create an exact model. Okay, but right now we're just doing it with shapes. Okay. All right, so the next problem. Okay, so now we're gonna have two shapes that kind of look like parallelograms, kind of leaning a little bit. If you end up drawing a square, it's fine. Just do your best to make them similar. Now notice that the next shape to the right is smaller, but that's okay. Okay, again, we're going to find the missing side. And when you work in the worksheet, or work on the worksheet, there'll be a question mark for the missing side. Okay. Now, again, corresponding sides. So first, before I start, I'm going to figure out which ones correspond. Well, in the worksheet, it's pretty easy to identify because they're kind of lined up with each other. But the 36 corresponds with the missing side. And the 42 corresponds with the 35. So what I'm going to set up is a proportion. Okay. The missing side, you can call it whatever you want. Let's just give it a letter, a variable. We'll say x in this case. You want to use x for everything, that's fine. So I'm going to put x first. Under x, I'm going to put the corresponding side. So the corresponding side is 36. Okay, so that's the left side of the equation. The right side of the equation, I'm going to go back to this shape first. Again, make sure you start with this shape first, or whatever shape you have the missing side on. Make sure you start with that when you write the number on the top. Okay, so 35 over 42. I'm going to put this other example kind of side by side. Actually, you know what? I'll do it after. I'll show you another example just so you can kind of get the idea here in a second. Okay. So now, if you guys remember these types of problems from quarter one, when you got, it's called a rational or a fraction type of problem, we want to get rid of that 36. So we're going to multiply both sides by 36. What happens here? These will cancel, and then I just multiply all this together. Now remember, when you multiply a fraction times a whole number, you only multiply that 36 times the number on the top. So I'm going to multiply 35 times 36. 35 times 36. Oops. It's 1260. And then I will divide by 42. So I'll use that answer feature down here. So we'll go answer divided by 42. 30. So x equals 30. So the missing side equals 30. Now I'm going to try to see if I can show this kind of side by side from the example I showed in the notes earlier today. And notice again, here was the missing side on the shape on the left. But I put that on top first, and then I put the corresponding side on the bottom. And then again, I went back to that first shape that has the missing side, and that number goes on top on the other side of the equation. And then I put the corresponding side on the bottom. So again, I'm showing you that because the shape of the missing side won't always be the one on the left. It might be the one on the right, but I still start with x on the top. Then I put the side that corresponds, or is the matching side. I put that on the bottom, and then on the next other side of the equation, I use the other two numbers. Okay. Okay. Last example. And actually, running out of time there. So what I'm going to do is I'm just going to show you guys real quick an example that I want to share with you guys because we are running out of time here. And just kind of how to go about this, but you guys will learn about it in the Ed puzzle. Is you'll get an example like this, and you can see that the shape is not oriented the same. And because of that, you're going to need to use this statement to match up everything. So in other words, EF goes to DC, which means this side goes to this side. And you use the letters to figure that out. Okay, and then you set up the same way like we did in the last problem. Okay. All right, so let me go back to the notes just so in case you guys are still copying those, but we are going to stop there. If you guys have any more questions, please. Otherwise, feel free. You guys can go. Have a good day. Don't forget the folders.
Bye.
Bye. Thank you. Have a good day.
Welcome. See you guys.
Bye. Thank you.
Bye. Thank you.
Bye.
Bye, Coach Osborne.
See ya.